Today I'm at Farris Automated Systems, a company that makes one-of-a-kind custom machines. This one behind me is making these. These are a little assembly that goes into your seatbelt, so that way when you hit the brakes, it makes sure that you don't die. It's important.
Farris got its start 14 years ago in owner and chief engineer Mark Johansen's basement. You know why? Well, because he didn't have a garage. Now, the custom machine builder is headquartered at a shop in Wales, Wisconsin, where his team designed and manufactured the company's latest custom creation, the CS sensor assembly. In just 35 weeks, the team of mechanical and electrical engineers and programmers went from a little more than a napkin sketch to a machine that is going to run nearly 12 million parts per year for a plastic molding company. The machine assembles a part that fits into your seatbelt housing. When you hit the brakes in your car, a ball bearing trips the lever which locks your seatbelt. The plastic molding company came to Farris because it needed a machine that not only snapped these levers into the housings, but also quality tested every part. And all of this had to happen in 1.2 seconds. A lot can happen in 1.2 seconds. First, the levers and housings are fed through a feeder bowl and into the assembly where machine vision cameras verify the part's dimensions. Faulty parts are rejected and good parts are placed into the housing. Once the lever has been placed into the housing, a valve shoots a short blast of air to perform a binding test. Basically, it pops the lever up and a laser sensor reads how long it takes to fall. Passing parts are grabbed by a gripper and unloaded, and parts that fail are dropped down a chute. In order to hit that 1.2 second mark, the machine has to be perfectly orchestrated, employing 8 different cameras, a robot, 9 valves, a couple of grippers, and 16 axes of motion among a host of other components. Farris machines nearly every part of the CS sensor assembly on its in-house CNC mills and lathes, including the primary fixture that they call the nest. The nest is a big part of what makes this machine special, because it can hold 5 different housings. Depending on the seatbelt, the housings are slightly different, sometimes as little as a 3-degree difference. On old machines, the plastics company would have to shut it down and change the setup to accommodate for the new part. The process took 8 hours. The new CS sensor assembly reads the floral pattern on the bottom of the housing. This tells the robot where to place it in the nest. Because the nest can accommodate every housing, part changeovers are now little more than filling the housing hopper with a new part. The rest is pretty much automated, taking an 8-hour process and making it happen in 10 minutes.
I'm David Manti. This is IEN Now.